Okay, this is a presentation on artificial intelligence and project management, and this is essentially from the PMBOK 8 perspective. PMBOK 8 has added in the back in Appendix 3 a whole section on artificial intelligence, if I can find it here. And usually what happens is that will be eventually get added in as one of the main parts of the PMBOK guide in a future version of it. But it's a short thing. The one thing that's nice about it, if you download this, go back on the very last, on page 244 on the back here, those of you that can see this, but there's a whole nice list of PMI resources on AI in project management. And some of these are free tutorials, and you get a badge that you can post on like your LinkedIn page, stuff like that. That's pretty nice. In addition to the Infinity, there's a lot of these resources out there for that. And so what I did is I went through this, plus I have another publication that I had done before that's a standalone publication, and I kind of tried to put together something that made sense in the context of what we've been talking about, without getting too in the weeds from a technical perspective. AI in project management needs to be understood as a strategic capability shift, not just a technological enhancement. Most of us tend to think of AI as a technological thing, but it's a shifting the way we do work all around. But the overall theme of this presentation is applying AI in the project management context, in that it's a shift in our capabilities as a project manager. So we'll talk about the foundations, define AI and understanding its architecture. We'll classify how AI operates using capability patterns. And then we'll move on to the adoption strategies. And there's the automation, assistance, and augmentation strategies. And then from there, we'll integrate into the PMBOK 8 performance domains and how it works in the life cycle. And then we'll talk about how this might change the role of a project manager. And so the idea is not to be too technical here, is to kind of look at this from a leadership and governance perspective. But artificial intelligence is transforming how project professionals plan, decide, and lead. And so, as I mentioned, we're focusing on changing the project management practice. It's not by replacing project managers or professionals, but it's changing the way we process information, in the way we make decisions, and the way we lead teams. And so this on the screen here, this illustrates how AI integrates into project management in a structured way. So its capabilities influence the focus areas influence the performance domains, that influences the lifecycle choices, things like that. And what's especially useful here is that the three strategies of AI implementation, and we'll go into this a little more detail later, but there's automation, usually for low complex rule-based situations. There's assistance. This is where outputs that require human review and validation. And then there's augmentation. And this is where we do more complex analysis. And we'll anchor this in the PMBOK 8 by looking at how AI supports the performance domains and how we'll apply across the project lifecycle. So as I mentioned earlier, the PMBOK 3, X3 is the Appendix 3 is helpful because it kind of lays this out in pretty simple terms in how this works. So by the end, we should be able to clarify what an AI use case is, select how AI fits in the different domains and hybrid environments, things like that, and then talk a little bit more, understand a little more about the ethical issues along with AI. So artificial intelligence in the project context, artificial intelligence expands project capabilities while increasing the need for governance and judgment. So artificial intelligence we shouldn't just view it as a tool layered into project management. It changes how work is performed. It's like a fundamental change. And so AI systems can learn from historical data, recognize patterns, generate outputs, optimize decisions. And so these are capabilities that allow us to work at more complexity at scale, if you will. So as AI becomes more pervasive, the role of project manager becomes more critical, not less. I think project management is probably one of the few careers out there that might not be totally replaceable by AI yet. I think it still requires that human element. I don't know. I don't know if y'all have been listening, but there's that new called OpenClaw. I don't know if you've heard of it, but it's something that was just released last week that it's basically an automation tool. It's like a personal automation, and it may do a lot of be able to do it, but it still requires the human involvement. It's basically what it means to me is that we'll be able to do much more complex projects and become much more productive than we are now. But the AI, it introduces new dimensions of like governance responsibility, ethical oversight, risk management, change management, and coordination. So it increases the need for adaptability and structured decision making. And so this slide kind of talks about how this just kind of gives you a visual of how that might work. So what is our artificial intelligence? So artificial intelligence refers to systems that learn, reason, and act to achieve defined goals within complex environments, basically by simulating human thought. So before we can categorize it, we need to define it. It's not simply software automation. It's not spreadsheets at scale. It's not dashboards. It's a system capable of perceiving patterns, predicting outcomes, planning or selecting actions towards defined objectives. And this allows machines to kind of operate in complex environments that previously required just solely human cognitive skills. And so this distinction matters in project management. So if we were just merely automating predefined rules, it's not intelligence that we're doing. It can adapt and learn from historical data, recognize new patterns, and improve performance. Then is where we're operating in the AI territory. So AI is about learning in goal-directed behavior in uncertain environments, which sounds a lot about what project management's been all about. And only after we understand that foundation, we can talk about machine learning, deep learning, generative versus predictive AI in different adoption strategies. So the taxonomy, AI taxonomy, from capability to technical foundation here. So AI is a layered architecture powering predictive and generative systems. And so at the foundation of AI is data, structured and unstructured data. And structured data is data that's organized in a defined format with rows and columns and consistent fields like schedules, cost records, resource assignments, risk logs, essentially tables, like you would see an Excel table, spreadsheets, something like that. Unstructured data is data that's not really neatly formatted or formatted at all, like documents like emails, meeting notes, contracts, chat messages, lessons learned, narratives, stakeholder feedback, all these types of unstructured things. It might require AI techniques like natural language processing to interpret. And so the systems, AI doesn't function without data. So the quality and the diversity and the governance of the data directly influences the quality of the AI outputs, just like garbage in and garbage out, right? We've been doing that for a while. So within machine learning, there's something called deep learning. Deep learning uses multi-layered neural networks that are capable of identifying complex nonlinear patterns. So most modern AI systems used in business applications rely on deep learning architectures. So there's machine learning, and then there's deep learning, and we'll have a little picture of a neural network. I'll show you what that looks like. But from deep learning, we can see there's two application branches that kind of fall off of that. One of them is predictive AI. Predictive AI focuses on forecasting or classification, anomaly detection, and optimization. And so in project management, this might be like schedule forecasting or risk modeling, cost refinement, estimation refinement, and predicting performance. So we could do a lot of earned value type stuff with the predictive stuff. Earned value is it's a reporting plus a forecasting tool. Generative AI focuses on creating new context, like text, summaries, structured documents, or recommendations. So in project management, this might include helping us with drafting risk registers, like risk identification and stuff. My position on things like this is that we can use generative AI to help us maybe analyze documents for risk from those enterprise and environmental assets that I've talked about, or it can look at industry, what's going on, and look for patterns, but it's still up to us to say, hey, that's something that's a risk that applies, but they certainly can augment our effectiveness in this area. But or they can help summarizing meeting outputs. And I know most of the meetings I've been in lately, they use either the Zoom AI or they use something else that then I get an email later that says, hey, here's the notes from the thing. So something like that instead of waiting. So under generative AI, we see that's where large language models live. The generative pre-trained GPTs. It's a specific implementation sample. It's not the entire field. So the GPTs are an extension of generative AI, which is an extension of deep learning, which is then an extension of machine learning. So it builds the capabilities and complexity build as the models grows. So this distinction here matters because AI, the term AI is essentially what we're talking about is an umbrella. It's like we talk about predictive project management. We talk about adaptive project management. We talk about hybrid. Those are umbrellas for tools and techniques and stuff that's underneath it. So AI is the umbrella for machine learning, for deep learning, and for predictive learning, and the large language models that come out. So we need to understand this so we don't misapply the tools. So we don't want to, for example, using generative models for predictive forecasting task without the right validation. So in other words, we want to know what we're using, what they need. So like deep learning can do unsupervised learning, where machine learning generally requires supervised learning. It's a difference. And that just means that there's either a machine or a human involved in the learning process. And so understanding the type of AI you're using determines how you're going to govern the project, how you're going to validate its output, and how you're going to integrate it into decision making. So if we use it to help us generate a risk register, is it a predictive or generative AI? It could be both, really. I mean, it could be predicting future risk or it could be identifying past risk. So, okay. So artificial intelligence, it's powered by learning algorithms. It's a lot of math that encode patterns from data into models capable of adaptation. So it's not AI, it's not magic, it's mathematics and computation applied at scale. So there's a lot of techniques that have to do with matrix algebra and calculus applied to these matrices. In the development of the GPUs, the graphical processing unit, those types of chips is what gave us the computational capability to do this stuff. So if you hear about them all buying this big, you read news articles, they're talking about all the people like XAI and ChatGPT, they're all buying up all of these GPUs. Well, they're buying because they need the computation. As the models get bigger, as the databases get bigger, they need more computational capabilities. And it's really the GPU architecture, NVIDIA, and it's a few others, that gave us the underlying technological architecture to be able to do this computation. And in the mathematics is something that we couldn't do on earlier, like what's called the von Neumann architecture, which is like what your laptop has, unless you've got a GPT in your laptop, a graphic GPU. But the algorithms begins with the data, both structured and unstructured, and the algorithms then process the data. And there's three primary learning paradigms that we're talking about. One, and we already talked about, supervised learning. This is where it learns from labeled examples. So like you have a spreadsheet with labels for the rows, and there's a lot of things you can do to pre-prep the data and structure it, and then it takes those and does a fast forward or forward process. So it processes the data and gives you some output. Then you compare the output, and then you can do back propagation and say, yes, this is good, no, and send it back. And you repeat that, and the algorithm will learn patterns and be able to predict like if you want to show it a picture of a cat and it shows you something that doesn't look like a cat, and you just keep going back and forth and tuning it. Then there's unsupervised learning. That's where it's kind of just detecting hidden patterns without labels. It goes through the data and just looks for relationships between all the different data elements. And then it comes out with outcome from that. Then there's reinforcement learning. This is learning through trial and error, which, like I said, is what I had done before. But they've set these things up now where there's a ReLU engine, but they can, through certain types of repetitive feedback, they can teach themselves basically doing this. And so the algorithms, the math, produces the models. And then in AI, especially deep learning, these models are layered neural networks capable of detecting these nonlinear. So when we deploy these models, they perform something called inference, which what that means is they apply what they've learned to new data. So as what they learned from the past data, they apply it to new data. And this produces the predictions, the classifications, the recommendation, and the generated content that we go on. And so many of these systems include a feedback loop that allows performance improvement over time. That's the large language models work this way. It has the transformer provides that feedback. And so for project management, this is important because understanding these different learning methods kind of gives us an indication of how reliable the outputs are, how much validation is required, where we might see bias, where it might emerge in the system. And I'm sure you've all heard of some of the GPTs giving you like hallucinated information. Their biases, especially ChatGPT, please you basically to give output that you would like. And it learns from your interaction. And even sometimes it'll ask you, let's say, which of this do you prefer? You like this output or this output? Some of the other ones like Grok, it's not quite that. So you have to be, so the ChatGPT is more biased into kind of moving you along. And where some of the other ones like Grok and Claude, they're less that way. So you got to understand that, what's going on. And then we need to know what governance mechanisms might be necessary if we're going to implement these things in our projects. So the technology here strengthens responsible adoption. This is a picture of a neural network, the two of them. The one on the left is a neural network. It's what they call a simple neural network. And the way this works is all these little, where's my mouse? All these little circles are called nodes. And each one of these stacks of nodes is a layer. And the first one here is the input layer. This is the hidden layer. And this is the output layer. So this input layer, so if you want to do like a picture, maybe these are all pixels in a picture on this input layer here. And on these lines, they don't show it here, but these lines represent where we calculate a bias. In other words, it's just a number that gives a weight. It says this is weighted, and it's the weight is on here. And the weight goes into an input into this little circle here. And what's in these circles is some kind of what they call an activation function. It's essentially just a program that takes the weight and does a statistical operations on it to kind of determine where this input would line up on a curve. And they've got ways to do this to try to get it to where it's either like +1 or -1. And if it's net positive, it basically, think about it as lighting this thing up. And then it sends it down here to the output and it generates an output. And if you're like doing a picture and it doesn't do it, you could send it back. Now, what we do with deep learning is we take this hidden layer and we add more hidden layers to it. And all these things here, these nodes in here, all these activation functions are busy either activating or not activating based on what the results are. And eventually it'll learn a pattern to take this input to produce the correct output. And it'll learn which pass in here and which of these which ones are activated when that's done. And once it knows which ones are activated, it can apply that to the next picture that comes in, the next picture of a cat. And maybe a different color, but it could probably still identify it, right? And what you can do eventually, once the pattern, you get your data, for the kind of the domain of your data, you can eventually remove or deactivate, remove these unused, unactivated nodes in the model and to save on computation, right? So, because even if you don't turn them off or remove them. They'll still go through the process of calculating the numbers. But if the pattern's established and it's learned, then you don't need them anymore. So we can do that. We can take that off. So it's really complicated. I've done some of the software for this. Python, the programming language, Python, and there's some libraries that come with some predefined models. So what you need to know, especially if you're trying to do this like in a job environment, what these models do, what they produce, and what they're doing. What we try to do is optimize this prediction capability. It's a term called gradient descent, and it's essentially we look at how far off we were from the correct answer and try to reduce that down to as close to zero as we can get it. And then once we do that, the model's optimized. And if you over-optimize, then what happens is the predictions tend to be off. If you under-optimize, the predictions are off. One's off on the over-optimization means you overshoot it, and the under-optimized means you undershoot it. You want to be as close to that zero number as you can be to optimize it. And so there's a whole bunch of math that goes into this, and it can be very complicated. But as I said, the input layer, that's where what they call features, which is essentially a column in a spreadsheet, enter the system, or it could be an image, or it could be a voice pattern, whatever that data is, or it could be text. And then there's hidden layers. This is where we learn, like I said, the patterns here are established in here. And so what we're trying to do is over repetitive inputs, we want to see the pattern, repetitive similar inputs, we want to see a pattern emerge. And that's where the machine learning takes place. So each connections between all these nodes have their own weight, which is just a number that gets entered into the activation function that influences how the output of the activation function. Then there's deep learning excels at nonlinear relationships, high dimensional, so big, large databases, multi-dimensional matrices like 20 by 20 matrices, stuff like that. Complex feature. In modern AI systems like including large language models rely heavily on these deep neural networks. And what they do in the large language models is they have another type of model. It's called a transformer model that is capable of looking at large databases of text. I'm not sure exactly what ChatGPT does now, but when I first started looking at it, it was doing like 20-something million tokens or something like that. I don't know what it's up to now. A token is basically part of a word that it uses. The tokens get passed into these neural networks. And so deep learning allows us to generate patterns in risk data, schedule variance, cost variance, stakeholder sentiment. Sentiment analysis is an interesting one. Sentiment analysis is where it could go like read all of the comments that on say a YouTube video, or what's the big, where you give people stars, what they call that thing, but it's the reporting, the feedback on a product, the customer feedback. It can go through and it can get the sentiment, how customers feel about that product. It could go through your emails and tell you about your sentiment, how you feel, how you might react to somebody. Yeah, it's pretty interesting sentiment analysis that can do that. So, but all this complexity, this increased complexity introduces it's reduced explainability. In other words, it's hard to explain what is happening. And as I mentioned, I think last week, we still don't know, the scientists that are involved in this, exactly how this interaction works. I mean, we can kind of explain it at a high level, but on the low level, they don't quite understand how these patterns emerge. I think we have better understanding on it now than we used to, but it's still kind of a mystery. It's one of those emergent things. But then there's higher data dependency. So now we got large and large databases, so there's much more dependency on the data. And then this also requires a lot more oversight because of that. So as the power of what we can do increases, so does our oversight responsibility for this. So some core AI capabilities are enabled by deep learning. So deep learning architectures enable systems to understand language, generate content, and interpret visual information. So on the previous slide, we talked about neural networks and deep learning, how that work. And what we're doing here is what do those architectures actually enable? So deep learning allows systems to extract high-level representations of complex data. It picks up nuances that we probably wouldn't pick up or wouldn't have the time to pick up. And from that capability, there's three categories that emerge. There's natural language processing. These are systems that analyze and interpret human language. They identify pattern, structure, and meaning in text. And second is the natural language generation. And this refers to systems that produce structured and coherent language outputs. And then there's computer vision. This refers to systems that can interpret visual data. They can identify objects, patterns, and features in images or video. And they're not separate technologies. They're application domains built upon deep learning. So deep learning is the underlying technology. And so understanding this, it avoids a common misunderstanding that AI is not just chatbots. Okay. Language processing, language generation, and visual intelligence are a parallel capability that emerges from these architectures that we talked about. And so now we can start talking about some of the more project-related stuff for this. There's artificial intelligence delivers the greatest value when it augments human judgment rather than replace it. So predictive AI forecasts outcomes from data where generative AI creates new context based on patterns. So the objective is not automation. We don't want to just automate work. The objective is augmentation. We want to augment what we do. And so augmented intelligence refers to systems that are designed to enhance human decision-making, not replace it. So things like intuition, emotional intelligence, ethical reasoning, content awareness, and creativity. And the machines bring statistical reasoning, pattern detection, long-scale data processing, speed, and consistency. And so each of these, the machines and the humans, we all have our strengths and weaknesses. Machines lack intuition and contextual judgment, and humans struggle with processing large volumes of probabilistic data. So when we combine these intentionally, we can produce stronger outcomes. And so in project environments, this means that AI can support analysis and synthesis of information. The project manager retains accountability and interpretation in that final intuitive type authority. And then augmented intelligence raises the standard for leadership. So the more capability we have, the more is expected, really. So this concept here prepares us to talk about automation versus augmentation, governance, and oversight, and how AI changes the role of the project manager. So automation versus intelligence. Automation repeats instructions and intelligence adapts and learns. And so before we move further into this, we need to talk about automation is not the same thing as intelligence, although automation, the concept of electronic automation does fall sort of under that AI umbrella that we talked about. But it's about repetition. It's not about generation or prediction. And it follows predefined instructions. So you give it the same input, it produces the same outputs every time. So there's no learning that takes place. There's no adaptation. There's no variability handling. And so earlier we defined artificial intelligence as the ability to perceive, predict, and plan, right? So if an automated system it doesn't do any of those things. It executes coded instructions that it's given. So an example, say you have a large company with an automated system that categorizes customer issues, incoming issues. So it would work off a keyword. So when certain keywords appear in the message, the system routes to the customer in that a live support representative can do. So in other words, as the keywords appear, it sends an automated email with instructions, and it'll do it every time to escalate the issue. That's automated, and it's not intelligent. So it doesn't understand the issue. It doesn't interpret context. It doesn't determine whether instructions will actively solve the problem. It just simply reacts. Now let's suppose that the management wants to reduce escalations and resolve more issues automatically without hiring new people. Well, that's going to introduce some intelligence into the system. And so if we implement AI, especially in this case, neural language processing, the system can interpret the customer's issue, understand the intent, and potentially generate a resolution rather than just forwarding it to people. And I've had this happen, call in, and even the companies that are kind of on above board on this, they'll say, hey, I'm your AI assistant, and I'm here to, there's some that you interact with it and you can kind of tell after a couple of, maybe a few interactions that you're talking to a bot, you're talking to an AI bot, but companies are actively employing this to do that. So then there's this, so the thing is we need to understand, how do we test the difference? How do we understand this? We can say, is there machine learning involved? Can the system improve over time with experience? And can the system determine the next steps to handle exceptions without any explicit human reprogramming or interaction? And if the answer is no to these questions, then the system's not intelligent. So that's how we can test. And it might be sophisticated, it might be efficient, but it's automation. And this distinction here matters because many of the tools are marketed as AI powered, but they're just advanced automation. Some of the project management tools. And so if we can't distinguish repetition from adaptation, we risk overestimating the capability and underestimating the requirements it's going to take to implement the software. So automation repeats, intelligence adapts. And that's an important distinction. There's 7 patterns of artificial intelligence. So AI applications can be classified into recurring capability patterns that clarify how intelligence is applied in practice. And so now that we've talked about what AI is in a technical perspective, we can classify how it shows up in a functional way. And so the industry researchers and practitioners have identified 7 reoccurring patterns in AI applications. And the patterns describe what the systems are doing, what they're fundamentally designed to do. And so there's a recognition pattern, identifying objects, images, or signals. Then there's predictive analytics and decisions. This is where we forecast outcomes and support decision-making. There's patterns and anomalies. That's detecting deviations, risk, or unusual behavior. Then there's hyper-personalization. This is tailoring experiences or recommendations at scale, like a recommendation engine. Then there's goal-driven systems. There's systems that pursue predefined objectives under constraints. You're given a goal and they go to work towards that goal. There's conversation and human interaction. These are language-based systems like chatbots and digital assistants. Then there's autonomous systems. These are systems that operate with limited or minimal human intervention. And so the value of this framework is the strategy involved. So instead of asking, should we use AI, we should ask which pattern applies to the problem we're trying to solve. And what this does, this moves sort of the discussion or the context from technology hype to capability alignment. And so for project management, this classification helps to determine the appropriate governance structures, maybe what risk exposure is good. That's kind of where sentiment analysis might come in. A life cycle integration, and what our human oversight requirements are. So the point of this slide is that AI is not one thing, it's a capability, it's a pattern of capabilities. And so understanding these patterns helps us to clarify which strategy we can apply to our projects. So strategies in AI adoption, organizations adopt AI through progressive steps, the automation, assistance, and augmentation strategies. So when organizations begin adopting AI, they rarely move directly to full transformation. Adoption typically progresses through different stages. And the first thing they do is they automate. Years ago, I worked at a place where that's what we did. We automated and then we added in the AI. But once we had the rules defined, then we could start adding the learning capability. So this is where AI in the automation is sometimes just advanced software used to replace repetitive and rule-based tasks. And the focus is efficiency, cost reduction, and throughput improvement. We're trying to get more efficient. And so at this stage, we're not fundamentally changing how decisions are made. We're just executing things faster. And so the governance complexity is low here because of the system is predictable. The second stage is assistance. Here, the AI begins generating outputs that support human decisions. And it may summarize information, suggest forecasts, draft documents, or surface insights. But the human remains involved. You've heard human in the loop. So the human reviews and human decide. This stage is where we start to see an increase in value, but it also increases our risk exposure. So now we need to validate the outputs. We need to monitor the system for bias. We need to make sure that we have good data integrity. And so assistance improves decision support, but also introduces significant oversight requirements. The third stage is augmentation. This is where everything kind of changes. It's no longer just performing tasks, but drafting suggestions. And it's expanding analytical capability, enhancing strategic reasoning, enabling more complex decision environments. We begin to collaborate with the machines. And the problem is, though, is the accountability doesn't transfer to the machine. As AI capability increases, so does the need for governments, ethical oversight, and professional judgment. So the PMBOK 3 makes an important point here that these stages are not just technological, but they represent a form of organizational maturity. Automation improves efficiency, assistance improves effectiveness, and augmentation improves capability. And so as organizations move across this continuum, the responsibility as project leaders increases. It doesn't decrease. And so the question for project professionals becomes, where is our organization at today in this continuum? And what are our governance structures? Are they aligned with this level of maturity? And because augmentation without oversight creates risk, but augmentation with structured governance creates a strategic alliance advantage. So it's important to understand kind of where we're at in the context. So AI, there's some use cases in the different automation. So automation applies AI to repetitive rule-based tasks, as we talked about, to increase efficiency. So within the project management context, automation applies primarily to structured repetitive rule-based work. So first there's process automation. So when we automate approvals, we automate compliance workflows, we automate documentation routing, we automate administrative controls, we're primarily strengthening our governance performance domain. And so automation ensures consistency, traceability, procedural integrity. And if we have a metrics attached to these workflows, it also supports the measurement domain, okay? Second, real-time monitoring. It's automated monitoring of schedule, cost, scope, and baselines. It enhances the measurement performance domain. It improves visibility and feedback loops. And when deviations signal emerging threats, it also interacts with the uncertainty domain. And at this level, it remains sort of threshold triggered, not repetitive. So real-time monitoring. And this is still in the automation strategy. Chatbots and automated communications, these primarily support stakeholder performance domain. They improve responsiveness and reduce friction. So we might have an automated status report that goes out, or they may be able to go in and pull information out using some kind of language model. But if we deploy these internally, it supports the team performance, but there's still rule-based communications with no adaptive emergent strategies involved. The fourth here is text automation. These are reminders, task routing, workflow balancing to enforce the team performance. They strengthen accountability structures and execution discipline. And in structured environments, they may also support planning, especially in the predictive domain. So we could automate some of the reminders and tasks and things like that. Then the next one here is automated meeting minutes and summaries. So this is team performance. It strengthens team performance by improving shared understanding and alignment. So when minutes are distributed to sponsors or to steering committees, it also supports our stakeholders and stakeholder performance. And when the documentation supports audit requirements, it supports the governance part of it. And so finally, we have automated risk mitigation actions. When predefined thresholds trigger rule-based responses, This supports the uncertainty performance domain. So if escalation policies are embedded, it can support governance, but it's important here to note that the automation stage risk response is also predefined. So the response is predefined, and the system does not interpret context or weigh any trade-offs. It just executes instructions. And so it's important to understand that automation doesn't replace leadership. Automation reduces friction, increases consistency, improves administrative efficiency, but it doesn't independently interpret any ambiguity or weigh trade-offs or any negative uncertainty. The capability that we have at the next level is the assistance. Assistance enhances project decision-making by providing analytical insight while retaining human judgment. So now we move from automation to assistance, and at this stage, AI is no longer simply executing rules. It's analyzing data and generating insights that inform human decision-making. So the distinction here is that the system provides insight and the human provides judgment. So we get insight from the system and we use our judgment to figure out which choice to make. So some examples here is the multi-criteria decision analysis. So AI can evaluate trade-offs across cost, schedule, risk, and strategic alignment. It can do all this simultaneously, but this directly strengthens the governance domain, particularly in the portfolio prioritization and value alignment. It can also support stakeholder domain, especially when we balance competing interests. But the final prioritization here remains on us. Okay. The next one here is predictive analytics for planning. AI can forecast timelines. You can forecast resource requirements and potential bottlenecks based on historical patterns. So this enhances our planning performance and our measurement. So it improves realism in project baseline and provides data-informed planning discipline. So we can leverage some of these. It was always easy to say, let's go back and look at previous project artifacts. But in reality, it was a difficult and tedious thing to do. And most people they gave it lip service, but they didn't do it. Here you can use an AI to do that, to do this augmentation or analysis for you. Early warning signals, even when traditional performance indicators look stable, AI can detect subtle patterns that maybe there's an emerging risk that we need to worry about. This supports our uncertainty domain and increases forecast and gives us more proactive response capability. Dynamic scheduling, AI can adjust schedules in response to shifting dependencies and resource availability or changing constraints. This supports our development approach and lifecycle definition, particularly in our hybrid and adaptive environments. And it can influence the team domain when workload balancing is involved. We can use AIs for this. Schedule conflict resolution. Here at the portfolio or program level, AI can identify resource bottlenecks and propose resolution scenarios. And this strengthens the team performance domain by improving coordination. It also supports the delivery domain because of improved conflict resolution, increases flow and throughput. And then finally, on this slide, there's the risk analysis. AI can model potential impacts of risk and costs, schedule, scope, or quality outcomes. And this strengthens our risk planning, our uncertainty domain by quantifying. So we can use AI to do some of the quantitative analysis for us that maybe would have been too prohibitive, or we didn't have the skills to do ourselves. We can leverage the AI for that. So it can support the measurement domain when we have probabilistic assessments are needed. So we can apply probabilities to measurement. So if the percentage of an outcome, we can do that, like the ranges of things I've talked about. So the key shift here is from automation to automation improves efficiency. Assistance improves analytical quality across governance, planning, measurement, uncertainty, lifecycle and approach development, team performance, and delivery. And so, but here the human still interprets the insight. The system doesn't own the decision. And so as our analytical sophistication increases, so does the need for better data governance, better model validation, bias monitoring again, and oversight structures. And so the next implementation strategy is augmentation. And augmentation expands strategic capability by combining AI-driven foresight with human judgment and accountability. So now we're combining it. Okay, up until now, we've kind of been in control of the final output. Now we're collaborating more with the machine. And so this is sort of the highest level of AI adoption is augmentation. And as I mentioned, automation improves efficiency, assistance improves analytical capability. Augmentation expands strategic capability. And so at this stage, the AI is not simply executing rules or generating reports, it's enhancing our reasoning in complex, ambiguous environments. And so we have, again, 6 more examples here, but brainstorming and idea generation. AI can surface emerging trends, synthesize cross-industry insights, and generate structured starting points for innovation. This supports the development approach in the lifecycle domain and the planning domains. It expands the creative aperture that humans will evaluate feasibility and strategic alignment. Second is scenario planning. AI can simulate multiple future states, trade-offs, and contingencies simultaneously. And this strengthens the planning domain and the uncertainty domain. This enables leaders to think probabilistic rather than linear. So we can start thinking of things more in terms of more nuanced instead of just a straight linear pattern. Baseline optimization, rather than just tracking baselines, AI can optimize scope, schedule, and cost trade-offs dynamically. So again, this supports planning and delivery domains, and it shifts from measurement to strategic refinement. So before we would just measure, now we can start looking at strategic refinement. Portfolio prioritization, AI can evaluate return on investment or resource constraints and strategic alignment across multiple initiatives. This strengthens the governance domain, but the political decisions remain a human because they involve value judgments, politics, and strategic content. Fifth here is the stakeholder sentiment analysis. Using a natural language processing, AI can analyze communication patterns to surface stakeholder concerns or emerging resistance, like I talked about with the customer reviews. It can monitor Slack chats and things like that to see what the sentiment is. This supports the stakeholder domain, and it increases emotional intelligence at scale. So it basically increases the emotional intelligence of us and the project. But this is where we need to ethical judgment, oversights involved, privacy issues, things like that. Then there's risk identification and assessment. AI can identify new risk patterns based on historical benchmarks and predictive modeling. And so this strengthens the uncertainty domain. So unlike automation, it's not rule triggered. So before it's, if this happens, then this happens. This one is saying this could happen. And it's a pattern-driven sort of forward-looking thing. It can help us identify and finalize the risk register. And the key distinction here is that augmentation doesn't replace leadership. It raises the bar for leadership. It makes it more important. So as AI capability increases, our responsibility for governance increases, our responsibility for ethical oversight increases, the need for good data integrity requirements increase, and accountability for the whole thing remains ours. So automation reduces workload, assistant improves insight, and augmentation expands strategic foresight. And so that's where project management becomes AI enabled, when we've done all these things. And we may have it's not unusual to have, I don't have a lot of experience with the augmentation stuff, but I do have quite a bit of experience with the automation and assistance. And it's not unusual to have all these things happening. You might have something that's going on in the project that's better suited towards automation, like time reporting and email routing or something like that. Then you might need like risk analysis and budget analysis, things like that. You might need more assistance. Then the augmentation part, especially in planning, you can start looking at more probabilistic outcomes, what might happen, to give you better insight into what's going on. The strategy, maturity, complexity, and human interaction. So as complexity of the project increases, AI shifts from automation to augmentation, which requires more human judgment and governance. And so what I see is that as we move more and more into augmentation in the projects, we're going to be able to move and scale up into much more complex projects, meaning there's much more dynamic interaction going on in the projects. And that's going to just increase our capability to produce value as we're doing this. So what this slide does is it brings everything, the two slides together, it brings these three strategies together. And so there's two dimensions here. There's complexity and there's a degree of human interaction. And so at the lowest level of complexity, we see automation, rule-based, repetitive tasks, reporting, monitoring, risk tracking. Human governance is minimal and human involvement is minimal. Government is procedural. We got rules we're following, and the machine executes things. As complexity increases, we move to assistance. Here, AI analyzes variability, it improves forecasts, it supports decision quality. Human involvement increases, and the oversight becomes analytical rather than procedural. And at the highest level of complexity, we see augmentation. These tasks involve ambiguity, uncertainty, and strategic interpretation, and continuous foresight. Humans provide judgment, accountability, and ethical framing. And this progression illustrates a central principle here, is that AI doesn't eliminate the project manager, no matter what you hear. So as complexity increases, technical execution decreases, strategic interpretation increases, and governance responsibility increases. So automation reduces effort, assistance improves decisions, and augmentation expands strategic capability. And so the more complex the environment, the more essential human leadership is. So this is how AI adapts across the different life cycles. So AI delivers value differently in predictive, adaptive, and hybrid life cycles by aligning with each model's decision cadence and uncertainty profile. So AI doesn't operate in isolation from the project lifecycle. Its value kind of depends heavily on the development approach. So in a predictive environment, AI strengthens precision. Here, AI enhances planning discipline, forecasting cost and schedule, detecting baseline deviations, quantifying probabilistic risk, primarily supports planning, measurement, and uncertainty, and increases control efficiency. So we're wanting to be predictive. One thing has to follow another. In adaptive environments, AI supports learning and responsiveness. So instead of optimizing baselines here, it helps reprioritize backlogs, analyze feedback loops, detect stakeholder sentiment shifts. So this strengthens the team, stakeholder delivery, and development approach. And AI increases responsiveness rather than rigidity. And in hybrid environments, AI becomes integrative, and it needs to reconcile the structured governance requirements involved with the hybrid iterative development cycles. In this case, AI supports portfolio optimization, resource balancing, and cross-team dependency analysis. And hybrid environments require the highest governance discipline. And so AI increases integration complexity. And so the main insight here is that predictive models, AI improves control. In adaptive models, AI improves adaptability. And in hybrid models, AI improves integration. And as the life cycle becomes more dynamic, the need for oversight and adjustment increases. So if we get a hybrid that's real dynamic, we're going to need more. AI shifts the project manager from maybe a task supervisor or a management mentality to a strategic integrator and a judgment leader. So up to this point, we've kind of focused on what AI can do. Now we shift, what does it mean for us? It doesn't eliminate the project manager, it changes the nature of our role. In lower complexity environments, automation removes that administrative friction in reporting and documentation and monitoring. So it removes some of the drudgery, tediousness out of that. In assistance scenarios, AI generates insights, but we need to interpret those insights. We need to have that capability. In augmentation scenarios, human judgment becomes even more critical. So the further up we go in the strategy, the more critical it becomes. So the project management increasingly becomes a systems integrator, a decision interpreter, a steward of governance, and a navigator of complexity. Okay, and it handles all this at scale. So the project AI handles all this too, along with the project manager. But the project manager handles accountability. We're still accountable for it. So as AI expands our capability, it raises the bar for leadership, adaptability, and ethical responsibility. So the future project manager is not replaced by AI, but we're amplified, and we're also being more accountable. So the stakes of what we're going to do is higher. So AI governance and ethical risk on these three strategies. So as AI capability increases, governance responsibility and ethical risk increase proportionally. So we often focus on what AI can do, its capability, but capability and governance rise together. So in automation environments, the risk is operational. We need to ensure that the rules are correct, the outputs are traceable, and the pipelines are secure, the data pipelines are secure. And so this is going to strengthen governance and measurement in that environment. In an assistance environment, risk becomes analytical. And now we need to question, is the model biased? Is the data representative? Are forecasts being misinterpreted? And so this affects the planning and uncertainty and measurement of our projects. Accountability here, or explainability, becomes the critical thing here. In augmentation environments, risk becomes strategic and ethical. AI begins influencing decisions about resource allocation, prioritization, stakeholder interpretation, and our risk appetite. Remember, we talked about in uncertainty, risk appetite, and risk threshold. And so now the government touches the stakeholder domain, the governance domain, and the delivery domain. So the project manager remains accountable for all those, but AI may generate the recommendation, but leadership owns the consequence. And so the professional insight here is that automation, it risks errors. And the problem with automation, if it has an error, generally it gets it's just a cascading thing. You make one mistake and you repeat that, it just builds on it. And it can be a big consequence. So leadership owns that consequence in automation. In the assistance, risk misinterpretation. So the AI is telling you something, you need to make sure you're interpreting that right. It's your responsibility. Augmentation, risk misjudgment, and misjudgment carries strategic consequences. So we want to make sure that our judgments are aligned. So as our maturity increases, so must our own ethical literacy, our own model. We need to model transparency in our decisions and model transparency in the AI as well. We need to improve data governance discipline. We need to work on our human oversight. And so all these things are amplified the more complex we get. So leading projects in the AI, this is the conclusion here. Artificial intelligence expands project capability, but human judgment remains the source of accountability and value. And so artificial intelligence is changing how projects are planned, executed, and led. And it's moving us from automating routine tasks to augmenting complex decision-making. And AI can identify patterns, forecast outcomes, and recommend response strategies, but it can't assume this accountability for that. And as these capabilities increase, the project manager's role is evolving to include integrating AI implementation strategies and AI-informed judgment into our project's performance. And so this expands what our projects can do. But the value of those capabilities still depends on how effectively we interpret and govern insights that they generate. And because in the end, AI may extend our capabilities and our project's capabilities, but it's our judgment that remains the source of accountability and value as project managers. So that is the end of that. Thank you.